Numbers over here, they are numbers that can be expressed as a fraction. But it is not just any other fraction. It must be a fraction that looks like this. A over B, where A and B are integers. Okay, so integers are, from what you know, whole numbers, including 0 and negative whole numbers. Okay, so there are so many different rational numbers that we can create. For example, 11 over 3, 5 over 1, which is the same as 5. We've got negative 8 over 51, so on and so forth. These are some examples. There are some irrational numbers. So the opposite of rational will be irrational. Then the definition is simply that we cannot express these numbers as a fraction a over b, where a and b are integers. So let me give you some examples. Square root of 2. For example, if you use your calculator to find out what is square root of 2, it gives you a whole mess of numbers. Do you think the number 1.41421356 is exact? Do you think this is exact, or does it actually carry on and on? Yeah, it actually carries on and on. If you have a more powerful calculator, it will show you more digits. Okay? It doesn't stop. Unlike, for example, 11 divided by 3. 11 over 3 shows you an exact value over here, which is 3 and 2 over 3. So if you use this or this button over here, the S and then with the arrow and D, it shows us that we can actually convert it to decimal. 3.66666, so many 6 with a 7. Do you think this is exact? Do you think this is the exact value? What's wrong with it? The 6 should go on forever, right? So what your calculator did was to do a little rounding off for you. The last 6, they changed it to a 7. But actually it continues on and on forever. So actually we can express it as 11 over 3 over here. This is exact. Okay? This value over here in decimal is not exact. Okay. So for example, square root 2, we've got another button on our calculator. Over here, shift, and this button at the bottom. And what is this symbol over here? Pi. This value is also irrational. You cannot express it as a fraction, despite what you have used in primary school. Have you always been using pi is approximately 22 over 7? Have you used this before? Did your teacher say approximately, or did your teacher say equals to? Did they say equals or approximately? Approximately, it is not equal to. Okay, so here I've got the value of pi, and I'm going to subtract 22 over 7. So if pi is exactly 22 over 7, my answer should be 0, isn't it? If my answer is not 0, it means that pi is not 22 over 7. So it is not. But this is a small number, which is why in our primary school, our teachers told us to use 22 over 7 to approximate. Roughly there only, but it's not exact. Okay? So pi cannot be equal to 22 over 7. Okay, so there are other examples, square root of 3, so on and so forth. So these are the two important ones that you need to know. Then we've got terminating and recurring decimals. Okay, this one you can go and watch the video and find out some examples of terminating and recurring decimals. Moving on. Negative numbers, was this covered in the video? Negative numbers? Yes, it was covered. So in our real life, when do we see negative numbers? Sorry? Use too much money, or your EZ-Link card. You use too much of it, then your value drops to negative. What else? You've been to very cold countries? So when it is snowing, maybe the temperature is negative in Celsius, degrees Celsius. When you go to some buildings overseas also, instead of B1, B2, which to us is basement 1, basement 2, they have negative levels also, -1, -2. Same idea. Okay, so here are some examples. 3 negative numbers, for example, -99, -5, negative pi over 4, for example. Is negative pi over 4 sorry, negative integer, cannot. So -1, for example. Okay, because they say integers. So these are examples. 3 negative fractions, okay, -5 over 8, -99 over 10, -1 over 2, for example. A number that is neither positive or negative, that will be 0. Okay, so these are some, this is another example which is covered in the video. Negative fraction, as long as it's a negative number. Yeah. Okay, what's a number line used for? Was that also covered in the video? Okay. Now I want to show you example 5. Draw a number line. When you draw number lines, please use a ruler. Okay, I don't have a ruler over here, so I use freehand. Your number line should be in pencil also. When you draw a number line, do you need to indicate, for example, from -5 to 5? -5, -4.5, -4, -3.5. Do we need to show so many of them? Or do we just need to show what is essential? Just what is required, okay? So they said that they want all the integers. That means I don't need this -4.5, I don't need a -3.5. So let's remove them. The next number must be -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. What do you think of this number line? Is this okay? Did I list down all the integers that I need? Did I list them down? Alright, right. I did. But is this good enough? What's the problem with this? Spacing. Which one has a poor spacing? 3 and 4. When you draw a number line, I do not need you to measure with your ruler, 1 cm for 1 unit. But I need it to be roughly the same size. Okay? This is obviously very bad. So make sure it is quite even. You have had a lot of practice in primary school drawing models where you have to split a bar into, for example, 3 equal parts. Use this estimation to help you also. Okay, I'm sure you can do it properly. Okay, next. Number line for part A. Integers greater than 0 but less than or equal to 5. So draw a number line. Now 0, 1, 2, 3, 4, and 5. This is my number line. Take note that there is an arrow sign over here to show that it continues on and on forever, yes? Okay, I haven't finished yet. This is my number line. I have not marked the points yet. Okay, so all this done in pencil. Use your pen or another color. We are going to mark out the integers greater than 0. So we got over here 1, 2, 3. Oops, this is still green. 1, 2, 3, and 4. So I have marked out the integers already. Okay, part B now. Prime numbers less than 14. Can you remind me again what's the smallest prime number? What is the smallest prime number? 2, yes. What should I start with my number line then? Can I start with 0 for my number line? Can I? I can start with 0. What do you think is the largest number that I should put on the other side? On the other end? Since I want prime numbers less than 14. Can I put 14? Can I put this as 14? I can. In fact, as long as the answers over here, which are 2, 3, 5, 7, what else? Then 11 and 13. As long as these numbers are shown on my number line, whatever smallest number you want to start with, whatever largest number you want to start with, it's up to you. Okay, so I think 0 to 14 is reasonable. So now I'm going to put in these numbers. 2, 3, 5, 7, 11, and 13. Do you think this is a good solution? A good answer? Yes or no? I've got all the numbers, right? So is this good enough? Why not? What do you mean by you can't compare? Must show all the numbers. So I must show from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Must I? I don't have to. However, is the spacing good enough for you? No, it's not. You have to try and draw it to scale. And in order to draw it to scale, is it going to be useful if I list everything out? 1 to 14? I think it's going to be useful in this case. So as you can see, there is no very fixed answer, as long as your work is presentable and it is reasonable. So in this instance, I think it is good for us to list down all the integers from, for example, 1 to all the way until 14. Okay, then from here, I will mark out the numbers. 2, 3, 5, 7, 11, and 13. So these are my prime numbers. So some things to take note. I would like your number lines to be to scale as far as possible. Okay, that means I don't want big gaps to represent small difference in numbers and then small gaps to represent big difference in numbers. To scale as far as possible. The other one is, it must be neat. Okay, so this means in pencil and ruler. Draw a number line for each of the following, mark the points representing. Okay, now for part A, let's be smart, let's be smart. Do you want to mark out all the integers from 1 until 55? No. So what is a good idea? What should our intervals be? 5? Okay, I think 5 is reasonable. So number line, let's start with 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, not enough space, so that is why we need to draw it in pencil so that you can edit. Oh, all the way until 55. 50 and 55. Mark the points. 5, 10, 25, 35, 45, and 55. Okay, please try part B and part C yourself now. Okay, so for those watching the video recording, part 1, draw a number line showing the integers from -3 to 5. You to go and divide this into 10 equal parts, because then the work is going to be crazy difficult, complex, confusing, very messy. So as far as possible, we just do a rough estimate, is good enough. So 4.8 is obviously closer to 5 than to 4. So put a dash, put 4.8. Okay, so you have already indicated on your number line. 4.8 is one of the numbers. If you want, you can put a cross on top also, this way. Okay, so 4.8 is done. The next number we require is 0.333. So it is 1/3. Visually divide this space over here between 1 and 2 into 3 equal parts and take the first 1/3. So this is our 1/3. Take note that you are supposed to write down the number that is shown in the question, not 0.333. The 0.333 above is just your estimate based on your calculator. So we're done with this, mark this out. And you get the idea, continue with the rest. You have 1 minute for this. I made a mistake over here. 1/3 is between 0 and 1. This is 1/3 over here. Thanks for pointing it out. Got less than. Less than or equal to. So I'm sure you can fill in the rest of this. Then draw a number line. Now earlier on before this, we were all dealing with discrete numbers. We were all dealing with integers or fractions. Numbers by themselves. But now we've got inequalities. So this is going to provide us a range of numbers. So how are we going to indicate a range of numbers on our number line? For part A, to indicate numbers that are integers that are greater than or equal to 3, but less than 3. So similarly, we draw a number line. But now my smaller value is -3, larger value is 3. Based on part A, I want numbers such as -2, -1, 0, 1, and 2 as well. Okay, so I've got my number line, but now I need to select the numbers that are within this range, greater than or equal to -3. Can I include -3? If it says greater than or equal to -3, can I include -3? Yes, I can. So mark it out. So -2 as well, -1, 0, 1, 2. Should I indicate 3? Cannot. Okay, because it's less than 3. So part A done. I'm sure you can do part B and part C also. And now we have to fill in the blanks.